Okay. uh, 2 weeks, maybe 3 weeks, actually, even February, we are going to practice the Sasmo questions. So you need to be familiar with Sasmo questions. It's not only Sasmo, okay? Let's say non-routine questions. All right. It really actually, how to say, improves the way you think about the problem. And also, we need to approach the questions carefully. And also, sometimes when you're thinking that, the idea comes, oh, Eldar, there may be some different way. All right, and if you're thinking and that is the best way, but never be convinced with your solution, I mean the decision, always leave a space or room of that there may be some better solution, better option, right? and uh, and especially that is what I learned from math. And a lot of times we solve the problem and you think that this is the best way, and other person solve this. Actually, sometimes I like the method more. Maybe it is shorter or more beautiful or nicer than your work. So guys, last time we started, we did a few questions and we stopped at question 10. Okay, and after I finished the question and I got the idea why, like sometimes the idea doesn't come, you cannot do anything. So we will continue the question from here. So last time we were talking about this question: how many right angle triangles can be formed by joining three vertices of a given regular um, 14 gon? Right? It's a polygon and it has 14 sides. If it is 13, if it is 15, actually, unfortunately, when you draw this, for example, if I just say this one is A1, A2, A3, A4, A5, A6, A7, A8, this will be A8, right? And as you see here, this diagonal is passing through the center of the circle, right? That is the center of the circle. And we know that any angle subtended by the diameter, it forms a right angle triangle. For example, using A1, let's say this one is A2, or let me just name label this vertices A3, A4, this one is A5, and this one is A6, and this one is A7, and this one is A9, and continue. Okay. Now using this A1, right? As you see here, A1, A8, it forms the diameter of the inscribed, or um, not inscribed, this not inside the polygon. Anyway, the circle, right? It is circumscribed, I think. Circle. That means that we know that we are just using this property if we are given a circle, and suppose that it doesn't look a circle, but suppose it's a circle, and that is a diameter. Okay, if you just pick any, let's say this one is B, if you just pick any point on the side of the circle and form or construct a triangle, and this angle is always 90 degrees, right? Why? Because that angle is subtended by this what is this, semicircle, right? That is 180. But this one is central angle, that is just half of this angle. This angle is 180. That's why it is equal to 90, right? If you remember, maybe also later we will study this, and we are talking about this kind of angle. Here we have this angle and this angle. Okay, so this alpha is subtended by this arc, right? This arc. So if it is alpha, the central angle, which is subtended by the same arc, it is just 2 times alpha. So if this one is 180, half of 180 is 90. That's why even if you just pick another point, for example, here, right, and form another triangle, and again, we actually get a right angle triangle. If you get another point here, for example, again, it gives right angle triangle. So now if I just start with one, A1, suppose that A1 is just one vertex of the right angle triangle. Now, how many right angle triangles I can form? Provided that A1 is one vertex of the triangle. And to be a right angle triangle, the second vertex must be A8, right? And after that, using A1, A2, A8, our first triangle will be this one, right? And the second one will be this one, right? And third one will be A1, A4, this one. How many with A1, A2? 1, 2, 3, 4, 5, 6, right? With just, if we take this A1 as a vertex, we can form how many? 1, 2, 3, 4, 5, 6. 6 right angle triangles. right? So now, how many points do we have here? This A1 is this one vertex. But similarly, how many points do we have here? Since we are talking about 14 gone, it has 14 sides, right? At the time for each vertex, by taking labeling this as one vertex of the triangle. So we have 14. So altogether we can form 6 times 14, 84 right angle triangles. So how many right angle triangles can be formed by joining 3 vertices of a given regular 14gon? We can form 84. So the answer is 84. Arad, Hussein, Eldar, Javid, any questions?
No.
No.
Guys, next question, and you will try. Okay, let me see how you solve this. That's a beautiful question also. The first element of the sequence is, let's say, a sub 1 or just a1 is equal to 0. And if n equals to 1, or n if n is greater than or equal to 1, then the other terms are given by this formula. A n plus 1 is equal to a n plus negative 1 to the power of n times n. The question is, find the value of k. What is k? It is an index, right? Index k, where a sub k is equal to 2013. Think a little bit, how do you solve this? And this is not so easy question, not also very hard, but also not so easy question. After 3 minutes, let's discuss it together. And after give a try, and after tell me the idea, what you think, how can you solve this? And
Teacher, what does it mean sub K? I mean, what does it mean sub anything?
sub?
Yes.
What do you mean?
Like here it said A sub N. What does it mean?
Where? You mean this one?
The one, no, the top one.
Top one. Okay, say again, which one? Arad. Okay.
What does it mean that?
It is nth term of the sequence. Now using this one, I can form the
Mm,
sequence, right? Sequence number A1, A2, A3, A4, and this one is nth term, and this one is n plus 1 term. And these two terms are connected to each other by this equation.
thank you.
Hello, teacher.
Hi, Narmin. Welcome. Narmin, we have just started. We just solving one question. Now we are doing question 10. And your friends here, they are thinking over this question. And after 2 minutes, if anybody gets the answer, we will discuss his answer. Otherwise, we will discuss it together or analyze this question together.
Oh, okay.
Hussein, are you thinking or already solving?
I'm thinking.
Solving. How are you solving?
I don't know.
Should we use guessing?
Yeah, can you guess? I don't think
No,
guessing is not
like
so easy.
guessing
Huh?
and nothing.
Yeah, because it's not a small number. I mean, it's a big number. Guessing is not easy if you're not the grandson of Mr. Einstein. Okay, guys, time's up. Oh, yeah, yeah. All right. Yes, Javid, Elda, Hussein, Arad, any idea at least?
No.
No.
I don't have an idea. Can you explain, please?
You have what?
I don't know the answer. Can you please explain it?
Okay. There may be some different ways, but what I think is, from the nature of this question, I think it is suggesting that if I just take this a to the a sub n, or just a n to the left hand side, what do we have here? I have this thing, right? A n plus 1 minus a n. On the right hand side, we have negative 1 to the power of n times n, right? So now, if I just actually write this expression when n equals 1, 2, 3, dot, dot, and k. Okay, this index n is changing from 1 to k. What happens here? If n equals 1, for example, here I have a2 and a1. Let me just write here. a2 minus a1. On the right hand side, I have here negative 1 to the power of 1 times 1. And how about if n equals 2? Here we have a3 minus a2. Here we have negative 1 squared times 2, right? And here we have a4 minus a3 is equal to negative 1 to the power of 3. And here we have 3. Dot, 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 it continues here. How about here we have k minus 1? K minus 1, and one number less than k minus 1 is a k minus 2, and here we have minus 1 to the power of k minus 2 times k minus 2. And the last one, because n is changing from 1 to k, the last one will be a sub k minus a sub k minus 1 will be equal to negative 1 to the power of k minus 1 times k minus 1. And actually, this method is used a lot in actual proving in some other questions. Maybe I will show you a bit later. Now, guys, let me just add side by side, okay? I add left-hand sides, all left-hand sides together, and also right-hand sides together, as if like we are solving a systems of equations. Now, if you add left-hand sides, what happens here? As you see here, the sign of A2, right? They are opposite here. A2 minus A2 is equal to 0. A3 minus A3 is equal to 0. So A4, here we have A4 is equal to 0. Well, to continue, here we have A sub k minus 1, A sub k minus 2, and A sub k minus 1, and here also we have A sub k minus 1. They're gone. On the left, what we have here? We have just A sub k minus a1. These two things left. How about on the right? Here we have, if you just calculate this one is, what is it? Negative 1. Second one is 2. This one is negative 3 and blah blah. If it is odd, right, it is minus. If it is even, it is plus. So here we have minus 1 plus 2, minus 3 plus 4, blah, blah, blah. And the last one is what we have here. Here we have plus negative 1 to the power of k minus 1 times, and here we have k minus 1. But actually, this one, the last one, k minus 1, is it even or odd? I don't know. So that's why now we have to consider two cases here. Now, because if it is odd, right, even, if I just write the numbers here, let's say here on the right, we have even number of terms. At the time, if you just calculate this, the sum is 1, and sum is 1, blah, blah, blah. Here we have just k minus 1 once, right? So my the first case is, suppose that k minus 1 is even. If it is even, right, here we have 1, 1, 1. On the right, left hand side, what is a sub k? A sub k is 2013. So here we have 2013 minus, what is a? 1 is equal to 0. On the right hand side, here we have k minus 1. What? No, 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 no. Here we have k minus 1 over 2, right? Because the sum of two terms is equal to 1. If we have k minus 1 terms, then your sum will be k minus 1 over 2. Now, if you just solve this equation, we get k. What is k? K equals 2 times 2013. It is 4026, and plus 1, 4027. Okay? And actually, that's the answer, because we have only one possible answer. And also here we will consider the second case. Okay, that is one possible answer. Number two, now suppose that this k minus 1 is odd number. Okay, if it is odd number, all right, here I can just add something. Okay, I can just add something, plus I can just here negative 1 to the power of k times k, right? And let me just add both sides, actually, this one. Okay, so what we have here, and also here, let me how to say, let me just subtract this also. Minus 1 to the power of k times k. I just added and subtracted, okay, or subtracted, added, doesn't matter. So since it is even, when it is even, uh, odd, right? If k minus 1 is odd, k is even. Now here we have even number of terms, right? What is the sum of these numbers is equal to k over 2. We are just pairing, right? Two terms here. So on the right, on the left hand side, a sub k minus 1. What is it? Again, here we have 2013 minus 0. On the right hand side, here we have k over 2, k over 2 minus, if k minus 1 is odd, that means that k is even, right? If k is even, this minus 1 to the power of k is just even, that's equal to just 1. And so here we have k. And here we have 2013 is equal to k over 2 minus k is minus 1 over 2k. Now from here, k is equal to minus 2026. And which is rejected. Why is it rejected? Yes, Hussein, what do you think? Why am I rejecting this answer? It cannot be the answer. Why?
I don't know.
Because it is negative number, right? Because this k is the index here, right? The index means it must be here. What is it? It must be positive number. Okay. So here the answer is, so our final answer is dot k is equal to 4027.
Teacher, but there is also something else as well.
Huh?
If you look at the pattern, like at the first one, a2 minus a1 is equal to that one. It means that a2 minus a1 is equal to negative 1.
Okay.
a3 minus a2 is equal to 2. So
Okay.
if you take the second one like in the first one is 1. If it be odd, it will be negative. If it be even, it will be even. And if you look, 2013 is odd, but it's not negative.
Arad, I didn't get your question. Are you asking a question, or you are saying something is wrong, or what are you trying to say here?
No, I mean, I didn't understand this part.
Huh?
Nothing. I think.
No, no. Are you talking about this k equals negative 2026 can be the answer, or what are you talking about?
And no, I just mixed one thing in the minusing. It's equal to. I mixed it. Nothing.
Okay. Now everything is clear, or still you have some doubt actually about this solution?
No, it's okay. Okay.
Okay. All right. Good. All right. Now, guys, let's continue then. Another question, and also this also beautiful question. How many 10-digit numbers only composed of 1, 2, and 3 exist, in which any two neighboring digits differ by 1? Okay. So first, did you understand the question, guys? So let's have a look, read it again. How many 10-digit numbers? And we are talking about a number which has 10 digits or formed using 10 digits. Only composed of 1, 2, 3. We are forming this 10-digit number using only 1, 2, and 3, in which any two neighboring digits differ by 1. Okay. So to do this one, let's say uh, it says that which any two neighboring digits differ by means that it should be either 1 2 2 1, right, or 3 2 2 3. That means that if you just pick, I mean starting from the left, either the first two or third or fourth or fifth and sixth, right, just take two digits, right, adjacent to each other, one of them must be 2, because 3 and 1, they cannot actually be next to each other because their difference is 2. Difference should be 1. That means that either 1 2 or 2 1, or 2 3 and 3 2. That means that every if you just pick any two digits, right, one of them must be 2. What does it mean? It means that now I have two possibilities. The first possibility is, suppose that my first digit starts with 2. At the time here I have 2. The second digit either 1 or 3, right? I don't know. And the next one again it should be 2. And next one I don't know. And also next one should be 2. Next one I don't know. And next one also should be 2. Next one either 1 or 3. And 1 2 3 4 5 6 7 8. It is 8. 1 2 2 2 2 2, right? And the second possibility is, how about if it starts either with 1 or 3? So maybe this number is something, and the second digit must be 2, right? And also next one is something. It is 2, something, 2, something, 2, 1, 2, 3, 4, something, 2, right? It must be this 10-digit number must be in this form. Otherwise, if you just pick any two numbers, they just adjacent to each other, right? And their difference will not be 1. For example, if it is 3 1, the difference is 2, or 1 3, the difference is 2. So actually one of the numbers must be 2. That is actually how to say the tricky point. And now in this, the first case, how many possible numbers do we have here? So here I can write either 1 or 3, right? It is 2 1 or 1 2 3. In both cases, the difference between these two numbers is 2. I mean 1.
Teacher?
So that means that here I have two possible answers. I can write either 1 or 3. And how about here? Also here I can write either 1 or 3. So I have two possible answers. And also here I can write either 1 or 3. I can write two possible answers. And also here I can write 1 or 3, two possible answers. And also here we have, I can write one, two, or three, two answers. So how many possible answers do we have then? Here we have 2 times 2 times 2 times 2 times 2, which is equal to 32. And also actually the second one is exactly similar to this. Also here we have 2 times 2 times 2 times 2, 32. And altogether, how many such possible 10-digit numbers do we have? We have 64. Yes, Arat.
Teacher, but shouldn't 2 to the power of n minus 1? And because n is here 5, so it should be 16.
What?
I mean, like, shouldn't it be like 2 to the power of n minus 1 in here?
Where?
In the solution.
Why?
Because like imagine we have only two numbers, 1 and 0. If we have two inputs, so it has to be like 2 to the power of, oh no, sorry, I mixed
Arat
it here.
here, but there's a condition here in which any two neighboring digits differ by 2. If we don't have this condition at the time, we can write like this. But here we have the condition. If you just pick any two digits, then your difference must be 1. Right? So the
Okay.
only way to write this 10-digit number, which actually satisfies this condition, is either the first case or the second case. In different way, you cannot write this. If you just pick any two digits, one of them must be 2. Otherwise, if it is not 2, what does it mean? Can we just write 1 and 3 next to each other? No, because the difference is 2. But in the condition, it says that they must differ by 1. It means that the difference must be 1. Hello? Narmin, Eldar, Hussein, Javed. Guys, do you understand or
Yes,
not clear?
yes, yes.
Okay, Mr. Eldar, Professor Arat, any more questions?
No. Today I'm a little bit sleepy, my mind is not working.
Your mind is not working, so charge it then. Maybe battery is dead. Do you have a charger?
No, I mean sleeping is charging and like sleeping.
Okay, Arat, what can we do? Actually, early hours, you are busy. And all right. Guys, another question. Can you just try this? Okay. And after that, we will discuss the question. How would you solve this question? I mean, I just want to listen. What is the idea behind solving this? You have 3 minutes. Have a look and think, and let's discuss this question. These are so beautiful questions. I don't know. I like this, and sometimes these questions I also ask this to my university students when they are bored of learning university courses. Last time I also asked them the candle question. They couldn't solve. Only one or two students solve it.
Did I think I have found?
Yes, Arad, I'm listening to you.
A negative 1 over 4 to the power of 5 minus 1 over 9.
Okay, what is your answer?
And when I did in calculator is negative about 0.11.
Negative 0.11.
About.
About minus 0.11.
Yes.
So that's the largest possible value of this expression.
Yes.
Okay, this is incorrect. Hussein, Eldar, Javid, Narmin. How about you guys? Javid, any idea? What do you think? How can we solve this problem? Just tell me the idea. Hussein, how about you?
No.
No idea at all? Are you sure?
1 minute.
Yes.
Narmin, how about you?
I don't know.
Okay, guys, look.
Did
And
I
the
have
trick.
found?
Yes,
Uh,
Arad, say again.
634.
634.
Yes.
634.
Yes.
How did you get it? Tell me the values of A. What is your A? What is your B? What is your C? What is your D?
A5. Oh, I'm sorry. I get me. Oh, negative 5.
Okay.
I took
B?
B as 4. It has to be negative 4, so
B, negative 4.
yes.
Okay.
It's incorrect. It's incorrect. Because I took B as positive 4.
Okay. My heart was going to stop beating my heart because it's negative numbers is not possible. Anyway, guys,
But
let's just do this together, okay? So we need to find, let's say, suppose that this expression is, what is it? Capital A, okay? So we are looking for the maximum value of capital A. What is this? All right. Since we are just adding, right, A to the power of B plus C to the power of D. Now, if actually I actually choose for B and D not even numbers, right? And for example, let's say negative 2 to the power of negative 3. Because this one is odd number, the answer will be negative here, right? And which is smaller. So I try to choose such numbers where each expression will be positive. To do this one, actually the exponents must be even numbers, number one. Number two is the second expression, for example, actually it doesn't matter. Just let me just take the second expression. This one, to get actually maximum value of this one, all right? So this D should be the greatest negative number here. So now if I choose this A as negative 1, okay, and to the power of negative 4, all answers are the same. And this CS actually, it will be positive. So uh, negative 5
teacher,
or
B has to be negative 2.
no, negative 4. So the C is, let's say, negative 3. And the D choose as negative 2. What is this? Here we have 1 over negative 1 to the power of 4 plus 1 over negative 3 squared, which is equal to, here we have 1 over 1 plus 1 over 9. That is equal to 10 over 9, or 1 and 1 over 9. Arad, if you choose here, for example, this one as 2, at the time, I will have to choose this one as 4. So negative 3 to the power of negative 4, that is, this will be like this. Negative 3 to the
I
power
forgot.
of negative 4. It will be very small number. Here we have 3 to the power of 4. Actually, this will be
81.
smaller than this. That's why I'm using bigger number for 1, because 1 to the power of anything is just 1.
No, because I forgot to see the negative, so I said like that.
Okay, that's also so beautiful question and tricky question and so nice question. So the answer is The largest possible value of this expression is 1 and 1/9. Okay. All right, guys, let's move to the next question then. Another question. This is just simple algebra. Have a look and think and just tell me the idea. How can you solve this? You have 3
It
minutes.
is simple.
It's easy. How?
Teacher, this is easy.
Okay, show me. How is it easy?
No, I mean, you are saying it is easy.
I mean, comparing to other questions, just a calculation, right?
Yes.
Easier, let's say, than other questions.
Teacher, but
And
it
really,
is
also,
so
I have no
simple.
idea how to solve this. Now I'm thinking. Let's think together for 3 minutes, and after that we will discuss.
Is calculator allowed?
No. For Sasmo, you're not allowed to use a calculator, right? You should solve this question with a calculator.
Can you repeat? Your voice didn't get.
Repeat what?
Your last sentence. Your last sentence didn't. Is me lagged.
In Sasmo, you are not allowed to use a calculator.
Even if it be trigonometry.
Yes, because in Sasmo, all questions are prepared in such a way that you can solve them without using a calculator. Okay?
Okay.
Yes. I'm teaching now. Okay. $20. Narmin, any idea? You get the answer?
I'll try to find.
Hussein, how about you? Mr. Hussein,
Yes, yes. What?
any idea? Are you solving? Did you solve it?
I am solving.
Okay.
How? Teacher, wait. Can you give 1 more minute?
Okay, 1 more minute.
Found nothing.
Anybody finished?
No.
All right. Narmin, shall we do it together? Narmin, shall we do it together or wait for you?
Can you wait now? I'll do.
Wait 1 more minute?
Yes.
Okay, 1 more minute.
Should we cancel the bottoms?
How?
Because everywhere doesn't have that one, so everywhere we like multiply by 2 over root of 1 plus 1 over 2. So everywhere it cancel, it go to the top of all of them. Then again we do that, so it become like again for 3 root of 2 plus 2 root of 3.
How about the denominators? Denominators are not the same, right?
Yes, but when we add, if we see it's just going like this. If we take
I mean,
like,
if denominators are not the same, how can you add the numerators?
no, I mean multiply all of them by a same number.
Same number.
So the first one will become 1 plus all of them with the denominator of bottom of that and the denominator of themselves. Then again you do it with the second number. It just go like this, so it become 1 plus 1 root of 2 plus 2 root of 1 plus 3 root of 2 plus, and this is all the time repeating. Is the answer 1?
I don't know.
Is it 2?
Narmin, any answer?
I did, but it doesn't make sense, so I'm doing it again.
Okay. We can keep doing, Narmin, or we can also just have a look. Usually in this kind of questions, first we have to rationalize the denominator, right? And otherwise it will be really hard to simplify this. And after that, we try to bring them into the same denominator or just separate each fraction. So now, as you see here, the conjugate of these numbers, right? If I just multiply numerator and denominator by this conjugate, and I'm just going to use this formula. We know that a squared minus b squared equals a minus b and a plus b. So doing this one, let me just this sum as s. So this s will be equal to, the first one will be, what is it? 2 times square root of 1 minus 1 times square root of 2. In the denominator, the square of this number minus square of this number. So that is 2 squared times 1 minus, is it minus? Yes, minus, right? It is, we are multiplying by this minus. Yes,
Why minus?
1 squared times 2. Okay, plus the second one, again multiply numerator and denominator by the conjugate of this one. So that is 3 times square root of 2
Okay.
minus 2 times square root of 3. So in the numerator we have 3 times square root of 2 minus 2 times square root of 3. In the denominator, square of the first number minus square of the second number. So here we have 3 squared times 2 minus 2 squared times 3. And it
Teacher,
continues, the last one. Yes, Arad.
why you're minusing?
Yeah, I should multiply it by its minus, right? If you just pick the second one, for example, 1 over 3 times square root of 2 plus 2 times square root of 3. So I should multiply numerator and denominator by this, 3 times square root of 2 minus 2 times square root of 3. In the denominator, 3 square root of 2 plus 2 square root of 3, and the minus 3 times square root of 2 minus 2 times square root of 3. Multiplied
Ah,
numerator and denominator by this.
understood.
A plus B, A minus B. Okay. So, all right. And the last term will be 2013 square root of 2012. And I don't need this. Just a minute. Yeah, I turned the fan, but now it is too strong. I changed direction. Now there's a lot of people sick in Cambodia flu because of the weather. So in the denominator, now we have here 2013 squared times 2012 minus 2012 squared times 2013. Now, if you just simplify the numerators, what is it actually? The common factor, just I'll show only one thing. Again, if you just look at this one, what is a common factor? 3 times 2 is a common factor. So inside we have 3 minus 2. 3 minus 2 is equal to 1. So just we have 3 times 2. Okay. So the first one is, I can just write it as 2 square root of 1 minus 1 square root of 2. Denominator, here we have 2 times 1 plus 3 square root of 2 minus 2 square root of 3. Denominator, here we have 3 times 2. The same thing continues, right? The last one is 2013, 2012 minus 2012 square root of 2013 over, here we have 2013 times 2012. Now again, here we have something like this, right? Here we have A plus B, actually minus or plus, it doesn't matter in math. I mean, yeah, just similar operations. Okay, let me just write here A minus B. In the denominator, here we have something like this, right? A times B. If I separate this, I can write it as A over A times B minus B over A times B, which is equal to 1 over B minus 1 over A, right? So now, using again this fact, guys, if I just separate these fractions, right, what do we have here? Let me just change the color here. If I separate this 2 is gone, right? And here we only have just 1. Minus here 1 is gone, right? Here we have square root of 2 over 2 plus, that's the first one. The second one is this 3 is gone. Here I have square root of 2 over 2 minus 2 is gone, square root of 3 over 3, right? Now you see the pattern here. The next one is the last here. Here we have what is it? It is 1, 2, 2, 3. Here we have 3, 4. Square root of 3 over 3 minus square root of 4 over 4 plus dot dot dot. And the last one is 2013 square root of 2012 over 2012 minus 2012 is gone, square root of 2013 over 2013. Now, as you see here, these two terms is equal to 0. These two terms is equal to 0, and also this one is equal to 0, and this one is equal to 0. What is that here? 1 minus, and if you here we have 2013 over 2013, or that's just equal to, what is it? 2013 minus square root of 2013. Or I can just leave it like this actually. Okay, that is 1 minus 2013 over 2013. Okay, or 2013 minus 1 over 2013. That is the answer. Yes, Javid, Hussein, Arad, Nami, any questions?
No.
Nami, did
No.
you understand everything? Is
No.
that clear?
Yeah, but
Yeah.
doesn't it have an easier way to do it?
Say again, Armin.
Doesn't it have an easier way to do it?
What?
Like fast, easier way to do it or faster?
Now I'm explaining this to you, Narmin. That's why it took time. But when you are doing yourself, you should do some calculations mentally, and you should be able to see this pattern. Okay. And because when I explain, it takes time. But usually, if I just do it for myself, I can do much faster. And when you're solving this, you don't talk to anybody, right? You're just thinking some steps you're doing mentally. You can do much faster. But that's the
Okay.
idea. I don't think if there's any other easier way than this, because the idea is number one in this kind of questions, we have to rationalize the denominators, and after that, let's see the pattern, okay? And after that, we call this, what is it? Binocular methods or something like this. Telescope method, I think. It's a lot
Oh,
of terms and just cancel them out. This telescope method, right? I don't know, guys. I don't think I don't know at least any different methods. And every time I saw these questions, I use this method. That is the easiest way, usually accepted easiest way. Guys, let's
okay.
move to the next question. Let's also have a look at another question. After that, we will finish the class. And this is easy question, right? And we have already done this. But I want you to try one more time, just 3 minutes, okay? Exactly 3 minutes after we will practice. Can you give a try and let's see if you get any answer or not? 3 minutes, time starts now. And that's our last question for today. Any answer?
In 1 minute.
1 minute. Okay. It is not that easy question.
If it was 4, it was easy, but 5 is a little bit tricky.
Yeah. Okay.
One more minute, 1 more minute.
Arat, we will continue, okay? But now other group is waiting for me. I have to finish this meeting, okay? It's no problem, guys. Also, this is a kind of homework. Also, other questions, if you have a time, just have a look at this. Do you have any idea? If you could solve some question, it would be great, okay? So next Tuesday, we will continue, okay? And also,
Okay.
and it's taking a bit long time, but let's see if there's a shorter way, guys. Okay, thank you very much. Have a nice
Goodbye,
weekend. See
teacher.
you next Tuesday. Bye bye.
Bye.